Now that you know how to do double integrals, you can find any probability and involving x and y just by integrating the joint density over the appropriate region. And the probability really ends there, as we said. After that, it's a matter of the geometry to identify the region and then calculus to carry out the integral. So let's do a couple of examples. We have the same joint density that we were using in the previous part. Let's find the chance that x is bigger than 0.6 and y is bigger than 0.5. So I need to find the region where this event occurs. The first thing before that is to remember the region where the density is positive, and that's the triangle that is bounded by, 0 and 1, and there's x, and there's y. And there are some key values here, which is 0.5 is pretty important, because y has to be bigger than that. And on the x side, it's 0.6. Now, x has to be bigger than 0.6, so all the action is going to be to the right of that vertical line. And y has to be bigger than 0.5, so all the action is going to be above this horizontal line. And so the region that we're integrating over is there. And you have to imagine the joint density surface over it, and we have to integrate that joint density over the shaded region. And so now we are all set. We are going to, we've done the geometry. Well, almost. We've identified the region. We still have to figure out the limits of integration. So we are going to integrate the joint density. I will fix x and integrate out y first, and then integrate out x. All right, so let's see. If we fix x here, then y can be anywhere here, and so the smallest it can be is 0.5, and the biggest it can be is this level, which, as we've seen before, is the same as x, because the diagonal line is the x equals y line. And now I ask myself, where could I have fixed x? I could have fixed x anywhere 0.6 and up, because that's what's required. And so here is where I'm fixing x, 0.6 and up. So let me write that down. Your probability is integral 0.6 to 1, 0.5 to x, 24 x minus y times y dy dx. The geometry is done, and now it's your turn to do the calculus. And you should get approximately 0.31 if you want to check your answer. One more example. We know that by definition of where the density is positive, y has to be less than x. But it doesn't have to be less than 3/4 of x. And so the question is asking for the chance that y is bigger than 3/4 of x, while of course still being below x. And so when x is 1, the key point is 3/4, so there's a half. When you're finding these probabilities, it's a very good idea to notice that there are some bounding lines involved. For example, y equals 3/4 x is a very good line to draw, and that has one goes through 0, 0, and also through the point 1 and 0.75. And you want capital Y to be above that line, and it's got to be below the x equals y line, so you are integrating your joint density function over that funny triangular shaped region there. And so you have to do the integral of fxy, always the option, and I tend to go for y first, but you could try the other way. So let me see. If I fix x, say here, then y goes from here to here. Basically, it's the value of y at the lower line to the value of y at the upper line, which at the lower line, y is 0.75x, and at the upper line, y is x. And where could I have fixed x? Well, I could have fixed x anywhere along here. I could have fixed x between 0 and 1. And now my geometry is done, and it comes down to a calculus problem. And I'll remind you what the density is. .75x to x of 24 x minus y. You do the calculus or you use SymPy, and you should get approximately 156.